Hello and welcome to the first video for chapter 16, which is called Random Variables. And I will say that this is one of my favorite subjects, and I think it's because it was pretty challenging at first, but then once I learned it, um, it wasn't that difficult. Okay, and a lot of it is the teaching of it and just doing a whole bunch of examples. So let's talk about a random variable, and this definition is very, very important because the first thing, it's a numerical value. It's a numerical value. So it can't be like a word, okay? It can't be a word. It can't be like A, B, C, D, or, okay? So it's a number, which is very important, okay? That is based on the outcome of a random event. Okay, so we've kind of worked with these things already, but now we're going to do a little bit more. Random variables are denoted by capital letters, okay? So it's a number that's based on the outcome of a random event, okay? We have two types. One is a discrete random variable. If all outcomes for a random event can be listed or countable, we call the random variable discrete. So let's say we roll a die. We roll a die. Do you believe that that is a discrete random variable? Well, let's see. What are all the outcomes? It is random because when you roll it, you don't know what's going to happen. That's a random event. Okay? So it could be a 1, 2, 3, 4, 5. Okay? Are they numbers? Yes. Okay? Can you count them? 1, 2, 3, 4, 5? Yes, they're countable. So, yes. So this is a discrete random variable. Okay? Let's talk about money. Let's say you did a fundraiser for a PTA. Okay? If you win $5. Okay? These are the possibilities. You could win $5. You could win $10. If you lose, you don't win any money. So is this a discrete random variable? Okay? Discrete random variable. If all outcomes of a random event can be listed, yes. I listed the 3. Are they numerical? Yes. Okay. Um, generally, money generally these are usually whole numbers. Okay, not always, because money could have a decimal, but money's countable. It can't go more than 2 decimals. Okay, for example, you could have $5.63. Okay, but that's countable. You could count that. Okay, but most of the time, like if I said, well, what about height? Let's say the height of 20 students. Okay, so I don't know how tall each student is. So the first student, I get a height. Let's say he's 70. Okay, let's say the height of the second one. Now see, this isn't countable because you could have 69.3246. So you have all these decimals. It's not countable. Okay, it's a numerical value. Okay, but you can't list all possible. I guess I should be a little careful, but that's where the countable comes in. They need to be countable, okay? Because you could say, well, you could list all these possibilities because there's only 20 of them, but they also have to be countable. All right, so those are just a few examples. When you read the book, you'll do the homework, you'll see a whole bunch of more examples, and it'll be pretty clear which ones are continuous and which ones aren't. Okay, if all outcomes cannot be listed, we call this random variable continuous. So these are generally things that are measurable. Okay, things that you could measure. Okay, things with decimals, a lot of decimals. I know this doesn't really make much sense, but you'll see. And in general, this is the important part. In general, continuous, and I abbreviate random variables as RV. Continuous random variables are listed under a curve. Okay? So for example, a normal curve. Anytime you have a normal curve, the variables under it are continuous. Okay? So for example, if these were heights, or let's say these were scores, remember that's your average, that's your standard deviation. These are continuous. Okay? You can't list all these, okay, in a table. Okay, so this is generally, in general, we use probability models for discrete random variables. Well, I shouldn't say that. Discrete and continuous. Okay? I need to be a little careful on how I word this stuff, because this is a list of all of them. So let me see, it can be listed, but they're not countable. Okay? These aren't countable. So let's talk about this. This is your probability model. Okay, the probability model. This is all it looks like. It has an x. Okay, that's big X. This is the probability of big X. Okay, each little x. This is a little x. Okay, is an outcome. So it's 2 outcomes all the way to xn outcomes. Okay, these are countable. This is the probability that x1 happens. This is the probability that x2 happens. xn just means that you have n outcomes. The probability that xn happens. Okay, so this is called a probability model. Okay, or a probability table. Well, that would be discrete. Well, if you have a situation in real life, like IQ scores, these could be IQ scores. Okay, these variables under here, this is the average, that's the mean. Okay, these are all continuous. Okay, these are continuous random variables. These are all discrete random variables. Discrete random variables. Okay, so the next video is going to just do a whole bunch of examples, and even if this is not that clear, you'll see that you'll get real good at setting these tables up, and you'll get real good at setting these curves up. We've actually worked with these before, so a lot of this is just going to be a review. But one of the most important things is it's a numerical value. Now every outcome might not have the same probabilities. Okay, every outcome might not have the same probabilities. So this numerical value is very, very important, because when we have a list of outcomes, okay, when we have a list of outcomes, so these are all of our outcomes, okay, and these are all of our outcomes here. What do we like to do if they're a number and it's statistics? There's two things we like to do, and that's find the average, which is the mean of all these numbers, okay, and the standard deviation of all these numbers. Here, if it's continuous, it's in general it's usually given. The mean and the standard deviation is given. But here they're going to give you these tables with these discrete random variables, and you're going to have to find the mean and the standard deviation. And the mean's actually called a weighted mean. If you've never heard that before, that just means that if you have a random variable that happens more often, then the probability is going to be higher. That needs to account more for the mean. Okay, when you find means, you're used to just adding all the numbers up. Well, you only could do that is if all the probabilities of every outcome are the same. If one random variable has a lot higher, has a higher probability, that means that that's weighted more. That random variable needs to be accounted for more. Okay, and we're going to do a whole bunch of examples for this discrete on the next video. Okay, so thanks for watching.